Welcome to Massive Open Online course on chemical process intensification. So, we have discussed in the previous module regarding different strategies of the process intensification. In this module, as a module 4, we will discuss something about the design techniques for the process intensification. So, in this module, we will discuss about the scales and stages of process intensification, and also other phenomena of the process intensification. So, in this lecture only scales and stages of the process intensifications will be discussed. So, you know that process intensification that happens with different scales, like it is micro, macro, or that meso scales. Except that some other parameters based on these scales will be actually considered for the process intensification. So, in this regard, what are those stages for that scales that also to be considered here in this lecture. So, first of all we have to actually go back to the objective of the process intensification little bit, because they are that process intensification background depends on the different aspects of that strategies for the sustainable design. So, for that sustainable design you have to go through some stages and scales. So, that is why what are those objective of that sustainable design that we have to know. We have already actually discussed about the selection of the best that process for the sustainable development, and in that case what should be the optimal process flow sheet, that also we have given in our earlier lectures. Even for that optimal process flow sheet what to consider, in that case you have to convert the specified raw materials into a specified desired products based on the process intensification and the process techniques. And also this sustainable process design will be of course subject to the predefined performance of the that process criteria. So, in that directions that we have to actually consider that what should be the scales, whether it will be the meso scale or micro scale or some other way that process can be intensified for the sustainable design. And in that case we have also discussed about that there are basically three steps for that process development for the sustainable way. In that case you have to improve the process first, and also that improvement may be from the that existing process whatever available, and from that you have to intensify the process to get the process improvement. And then sustainable process design also there based on that early stage design. So, what are the stages in earlier stage they have used, how to actually intensify, how to actually change that design to get the more sustainable way of the process intensification, that should be considered. So, that we have discussed. So, for this that process improvement or sustainable process design based on this earlier stage design, in that case you have to of course analyze the problem, and you have to set the targets of that improvement that will be defined based on the that case design also according to your specific problem. And in that case mean target of that sustainable process development to get the solutions and evaluate that process output or yield based on that that reduction management of waste, even how to increase the yield, even also how to improve the environmental that negative effect based on this sustainable development. And also parallelly you have to think about that how to generate the alternatives way to actually get the better way of synthesis, even better way of design, and better way of other yield of the process. So, in that case new novel and innovative process alternatives should be actually thought about that. So, and all those things will be actually based on that that base case studies whether in the chemical process or some other mechanical process, that should be considered. So, in that case we know that sustainable design is defined as the design of process flow sheets that corresponds to lower values of set of targeted performance and also the criteria based on the economical, operational and environmental factors. So, the sustainable design is obtained through the improvements that reference to the early stage design, also called reference design or base case design, and for that you have to consider all those this economical, operational and environmental factors for that design. Now, what are those role of process synthesis for the process design, that also we have discussed. So, we have to know that things also, the role of process synthesis in finding the early stage design and more sustainable design, that is to generate the feasible process alternatives, and also that alternatives are generally trial and error method, rule based heuristics, and also process integration, mass and energy, process optimization, process intensification and also many more you can say. So, these are the process synthesis role for the process design, and also the improvements that process design are related to the physical system, like that what are the materials you are using, and also what are the solvents you are using, what are the energy that you are going to consider for that that economic consumption of the energy. So, that should be considered also. So, if you are synthesize some catalyst, that the screening and the selection of the novel catalyst for the reactive system that you have to consider, and also what will be the characterization for those catalyst particles, that also to be considered for the process design. And what are the solvents that you are going to use for that particular process, that also to be taken care, because some solvents may be hazardous and some solvents may be giving the less intensity of the that separability of the compound from the other components. So, in that case the integration, generation of the screening and the selection of the environmentally friendly solvents that is not hazardous, that you have to consider for the separation process. And materials, the design of new materials of course to be considered for that design of novel innovative unit operations, and in that case you have to integrate those things like combination of the reaction, combination of the separation and also reaction separation, both things. That is why the reactive distillation, reactive extraction, even that reactive adsorption, that is reaction as well as adsorption, both operations are coming for that simultaneous operation of these unit operations. So, in that case materials should be used properly, where that reactions, whenever reactions will be going on, whether those materials will be converted to other materials or not, because that materials may be used for separation, but those materials may be reacting with the other that reactants. So, that is why whenever you are considering the integrated process of that reaction as well as that separation process, so you have to think about that, like that there is an example, suppose ozonation of that there is a application of process intensification of like advanced oxidation process. In that case sometimes micro bubble systems, micro cavitations there, ozone micro bubbles are producing to actually convert the arsenic 3, which is necessarily that available in the groundwater, that arsenic 3 is to be converted to the arsenic 5. So, this is the reaction parts. Now, if you consider the reaction as well as adsorption of that, what is that derivative of that arsenic 3 to the arsenic 5, that arsenic 5 to be adsorbed on the some other materials, like if you are using the resin materials, then you have to think about that whenever you are going to combine these processes, whether these resin materials which is being used for that adsorption purpose should not be actually converted by advanced oxidation of ozone. So, that should not be reacting with the ozone gas. So, that is why you have to think about the materials whenever you are going to use for separation process after reactions. So, in that case for design of that particular process, that the consideration of the material properties are very important. Again, that use of the process integration, that sometimes to create more sustainable process alternatives, in that case you have to use some energy, maybe that energy will be more consumed, or maybe sometimes the if you are integrating the process, less number of equipment should be used, in that case less energy may be used. So, that energy consideration also to be taken care of, improvement of the process design for the process intensification. Now, what are the different scales of the process intensification for sustainable design? You know that different stages, different that scale you have to think about that for the process intensification. At the plant process scale, at the task scale, at the molecular scale, there are three actually scales are available to get the sustainable design for the process intensification. So, at the unit operation scale and other, the phase and phenomena scale are actually conjugated with that, the task scale and molecular scale. Though we have we can subdivided this the different scales as that plant scale, task scale and molecular scale, and also unit operation scale and also phenomena scale. Now, to apply the process intensification, a combination of the operations, tasks and or phenomena based scale need to occur simultaneously, subject to the specified objectives and constraints of the process. So, whenever you are considering the process intensification at these various stages or various scales, that in that case you have to consider the what are the objectives and constraints of the process. So, that should be actually taken care for the analysis of process yield based on these different stages or scales. Now, at the plant or process scale, in that case all the plant scale you have to consider the entire process. What are the entire process, like here that maybe reaction, maybe adsorption, maybe extraction, all the process at a time you have to consider at the plant or process scale. And at the unit operation scale, in that case individual equipment that constitute the final process design should be considered, and also perceived risks on the process performance can be derived from a lack of understanding of the process fundamentals. And also in that case you will see the performance of the unit operations may be that there are several unit operations, like that extraction process is one unit operation, mass transfer is one unit operations, that absorption is one unit operations, heat transfer is one unit operations. So, in that case the performance all those unit operations may change with the scale of the operations. That is why macro to micro, even nano scale stage is coming. So, in that case performance of the unit operations depends on the scale of the operation. Now, process development involving reduction in equipment sizes, in that case one scale for that unit operation, this actually lead to improvements in reaction kinetics, better energy efficiency, you can say reduction in capital cost and improvement in the process safety. So, this process development involving the reduction equipment size will give you this benefit. And also if you reduce the size of the equipment, in that case it will increase the throughput of the process, and also it will reduce the equipment hold up or inventory you can say, and also reduces the uses of utilities and raw materials. And also in that case the process that equipment efficiency also will be increased by reducing the size of the equipment. Now, at the task scale, what is that? That at the task scale generally it is defined as the function that performed by a unit operation. Like that if you are suppose design an equipment based on this process intensification way, that what will be the that efficiency of that process or yield of the process. Now, you have to make a function that will be depending on several factors, that functions that is called tasks that performed by each unit operation, that should be identified and analyzed based on the operating variables. So, a hybrid or intensified unit operation if you are considering, In that case, it will enhance the function or one or more unit operations for performing a task or a set of tasks through a new design of the unit operation or the combination of more than one unit operations there. So, that is why at the task scale you have to think about that whether you are going to design the process as a hybrid or intensified unit operations or not. So, in that case if you are considering, then you have to enhance the function of one or more unit operations for the performing a task or a set of tasks through a new design of that unit operation. Now, a flash vessel or a distillation column that represents the separation tasks is an example here. So, separation tasks, what is the process separation efficiency? That distillation column will give you that separation efficiency. Now, that separation efficiency depends on several that factors, whether you are reducing the capital cost, whether you are reducing the material used, whether reducing the that equipment size, whether you are using that some other materials, or you are using design or design that unit based on the other geometric variables or not. So, all those things to be considered to actually analyze these tasks. Now, reactive distillation is a combination of the reaction and separation. In that case, what is the efficiency of that integrating system of reactive distillation based on that reactor size, distillation column size and different operating parameters. And if you are conjugating this unit operation, you will get the that one single unit, and that single unit will give you the better way of that process design to get the better yield. Similarly, other membrane reactor is also one combination of reaction in situ removal of reactants or products based on this membrane that efficiency. There are several membranes of course will come, maybe that ultra and nano filtration based that membrane. So, there are different types of membranes that will give you the enhancement of the process, and also your design will be a sustainable design based on this. At the phenomena scale, the phenomena that in that case you have to build a certain block, that concept block you can say, or phenomena building blocks that satisfy the tasks to be performed are identified and analyzed. So, in that case you have to think that different building blocks like that separation, that reaction, that mixing, that heat transfer. So, all other that phenomena to be considered as a that phenomena building blocks. So, you have to that identify and also analyzed those that phenomena based building blocks whenever you are going to that synthesize any chemicals based on the process intensification. So, in that case this phenomena building blocks is considered as the smallest unit that performs a task in a process. So, that is why in the suppose a mixing phenomena building blocks performs a mixing tasks there. So, how mixing, whether this mixing can be intensified or not, whether you can reduce the back mixing or not, whether you are designing the equipment, you are designing the device in such way that your that back mixing will be less. So, you can provide some provision of mechanical parts where that that internal circulation of the fluid elements will be reduced to get the reduced back mixing. So, this mixing task will give you that that phenomena based building block for the conceptual process intensification and sustainable design. Now, what are that phenomena scale? Actually, if we consider the simultaneous phenomena building blocks, in that case combination of one or more phenomena building blocks to be considered as a whole for analyzing the whole process intensification or whole design. So, in that case you have to predefine the combination rules either way, whether after reactions it will be adsorption, after reaction it will be mixing, after reaction it will be that adsorption, or after mixing it will be some other chemical operations or not, or to get the certain process output, whether that mixing, separation, reactions, all those things to be considered at a time or not, and how it will be actually interacting, and also the effects on the process output there. So, simultaneous phenomena, building block, mixing, as well as that fluid flow phenomena, flow patterns, that should be considered. So, simultaneous phenomena should be considered for the process design. That most chemical processes can be represented by different combinations of mass, energy and momentum transfer. In that case, phenomena like that mixing, heating, cooling, reaction, phase control, phase transition, phase separation and dividing rules should be considered for the process design. A dividing phenomena divides a stream into a one or more streams. So, that also to be considered. Suppose you want to segregate that fluid stream, so you have to consider the divider. So, dividing tools also should be there for the considering of the process design as a phenomena scale. And at the molecular scale, mainly considered for the reactive systems here, and in that case the molecular behavior of the molecules that affect the phenomena are considered. So, in this way you can the links between different that scales are generally established, and it will allow the search in the various scales to find out the design of the new, innovative and the sustainable process and design of the new process. So, that is why you have to first that think about the how actually all those scales are linked before that going to the design of that sustainable process. Now, let us have this that links between the scales by this process diagram here. You will see if we divide it a certain process into different scales like process scales, unit operation scales, task scales and phenomena scales. So, in this case you will see that in the process scales there may be that reactions, there may be that some other chemical synthesis process in the reactor. So, or what are the different unit operations to be considered there, and after that that unit operations that may be different types of unit operations will be considered there, like after integration, after that reactions, what type of unit operation to be considered for the separation of that products, and that separations will depend on the different tasks like that reactions, separations and separation, different types of tasks will be there, and that tasks based on the operating variables what is called the phenomena based like hydrodynamics. So, in that case mixing, reaction, phase contact, phase transition, cooling, heating, even dividing of that fluid streams, flow pattern. So, all those things to be considered based on the phenomena, like what type of fluids are giving that that reaction, what types of fluids, and based on the fluid properties how it will be actually changing the mixing characteristics, how phase contact will be there, whether it will be miscible or immiscible, whether it should be any change whenever it will become from the liquid to the gaseous phase. So, at that phase transition what will happen, that should be considered. Even during that phase separation, what actually a residence time of that contact of the phases, what should be the that heating energy to be considered, what will be the cooling energy to be considered for that particular phase separation. So, it is to be considered. So, there are these four tasks, four that scales. At these four scales we are going to consider the that reaction scale, unit operation scale, task scale and phenomena scales. So, in this case if you go from the lower scales to the higher scale, you will see all those things to be considered here: reaction, mixing phenomena, phase mixing phenomena, phase transition, dividing rule, cooling, heating, all those phenomena. Whereas, if you are considering the scale to the process without considering all those that phenomena or tasks, then you can also get the overall output, but to get the that intensified way of output, you have to consider this task phenomena scales also. So, that is why there is a link between this process, unit operation, task and phenomena. So, at the lower scales a small set of tasks and phenomena are employed to represent various process flow sheets alternatives. So, in the task scales you can consider that flow sheet of reaction, flow sheet of separation, flow sheet of that heating, flow sheet of cooling, all those things. Now, all those things flow sheet that depends on that mixing and cooling, heating and energy supplied there. So, at the lower scales you have to consider the alternatives of a small set of tasks and phenomena. Now, moving from the higher to the lower scale, that will increase the possibility of the process innovation, because in that case that functions of unit operations can be generated through the combination of tasks leading to new flow sheet alternatives. And also if you are thinking about a new ways to perform tasks, in that case the generation of that tasks can be done by combining different phenomena leading to the generation of novel and that more sustainable flow sheet alternatives. So, therefore, if a process are designed at a scale that is lower than the unit operation scale, there is an increased chance of that finding a more sustainable overall process design there. So, it is very important that always if you are going to the lower scale from the higher scale, that you are thinking of new alternatives and also new ways of performing the tasks to be considered. Now, process integration can be that considered in other special cases according to the that Halewagi, that he actually given that some statement for this the process integration to process design there. So, according to him that the process integration can be considered as a special case of process intensification and is commonly defined as the design and analysis of the best network for the mass and energy utilization that is applied to the design and operation of new as well as that existing processes. So, that is why the process integration is one of the important that backbone of the process design for the intensification of the process. Now, in that case this process integration is concerned with two integration concepts. One is mass integration, another is energy integration. So, for the mass integration, the efficient utilization of the mass to be considered here within the process by analyzing and optimizing the mass flows within the process. And also in the case of energy integration, the efficient utilization of the energy to be considered, like if you are using heat energy, then you have to integrate that heat part where by the one process if heat is that releasing that released heat, how to actually utilize for the second process. So, that should be considered. That is why energy integration concept is coming, because the wastage of the heat energy, wastage of the energy to be reused for the other process. So, based on that energy integration process, this that process integration can be designed. So, that is why efficient utilization of the energy within the process through the analysis and optimization of the energy needs within the process. Now, another important points which is to be remembered, that whenever you are considering that process intensification for the utilization of the concepts from the process integration. So, in that case, in order to design that hybrid or process integration or intensified unit operations, that should integrate the mass and energy within a single unit operation, or you can reduce the number of unit operations by just conjugating that two or more unit operations in a single unit. And also how it will be intensified, that is also to be compared with the existing process. So, to analyze those, that process integration, whether it should be intensified or not, what times of that or what will be the factor of that intensification, that also to be considered for that based on the existing conventional process. So, if we are considering the process integration, that should be actually conjugated with that mass integration and energy integration, and it will give you the process intensification. And to design of that process integration unit in a sustainable way, that you have to consider that novel solvents which are being used, novel materials which is to be used, and also novel unit operations, like whether equipment, what type of equipments, and what are the different processes, as well as for the mass transfer and that heat transfer. So, all those things to be considered for the that process integration. There are 3 stages sustainable process design for the process integration. In that case, that you have to consider that feasible design. In that case, you have to think about that, how to design that process, how to synthesize the process, and also you have to analyze that process for the feasible design. And also for the innovative sustainable design, that you have to think about that, whether it should be economic or not, whether it should be life cycle based or not, that life cycle analysis should be required, and also intensified synthesis to be considered for that. So, according to that Bobby et al. 2015, that for the feasible design and innovative sustainable design, based on this design process, synthesis and analysis, and also that economic sustainability, and also that life cycle analysis, they actually suggested that you have to search some space for that unit operations by stage. In that case, he has suggested the 3 stages for the synthesis, for the design and analysis, and the innovation of design. So, for the first stage, according to them, that they told that some flow sheet should be considered, and for that particular well known unit operation, and based on that economic analysis, you have to design that integrated system in a stage 2 based on this economic analysis, and after that you have to design that system in such way that you have to consider the flow sheet, well known intensified existing and novel unit operations there, and based on which that you have to couple this flow sheet, well known and intensified existing and novel unit operations for that innovative design. So, according to that Bobby et al., we can say that to search that unit operation for the feasible design and innovative sustainable design, you have to consider the flow sheet, you have to consider the that intensified existing and novel unit operations for that. Now, in the first stage, you have to consider the optimal processing paths for that flow sheet, and which is to be actually synthesized to convert a set of raw materials into a desired set of products. Now, in the second stage, that optimal processing path, that is called flow sheet, to be selected for further study, and also includes the identification of the process bottlenecks or hotspots, like is there any that uniformity of the distribution of the heat or energy or mass is there or not, and these will actually lead to more sustainable and innovative solutions. And at the end of the stage, you have to consider the methods that the process intensification can be applied to generate process alternatives, and also the desired targets for the process improvements. As an example, if we consider the case of heat integration, so in that case you have to consider the combination of heat exchanger as an example that needs to reduce the temperature of the stream with another that needs to increase the temperature of the stream. That means from the one unit, whatever fluid stream is coming, if its temperature is higher, and that temperature if you are going to utilize for the second operation, second that a stream like unit 1 and unit 2. In the unit 1, output streams having the temperature higher than the that unit 1. In the unit 2, if you suppose want to cool down the, or if you want to that reduce the temperature of that process, then you can easily supply this output heat energy to reduce that second operation in such way that some cooling materials to be used there. So, in that way that you have to combine the heat exchanger where output energy can be used for the other operations. So, integration in this case saves energy as well as cooling medium, and thereby makes the process after integration more sustainable way. Now, here as an example of 3-stage process is given for the production of methyl acetate by reaction of methanol and acetic acid. Here see the process flow sheet. In this case on the first stage you will see there is a reaction scale. Here in this case methanol and acetic acids are used in this reactor, and after that reactions that some ethanol or ethyl acetate will be formed, and that ethyl acetate with solvents that will be that separated by some other unit operations there. In this case this is called unit operation stage, that is called extractive distillation, and after that there will be several other unit operations where you can segregate or you can separate those products and byproducts by several that unit operation. So, in that case you will see number of unit operations be that decreased by just integrating those processes in a single unit, and of course yield of the product should be increased to its certain level of purity. And also, can the process be made more sustainable? Of course the process can be more sustainable based on this that process integration. If you are doing individual operations separately, and if you are considering all these that materials and energy, then you can get, there is a chance to that loss of more energy, loss of more materials, and loss of more that capital. So, in that case you have to integrate all those separate process in a that integrating way, so that you can save your energy and also you can improve your yield of the process. Now, another example, combination of operations, tasks and or phenomena would lead to an alternative that is better than the base case design according to a set of performance criteria and subject to the principal requirements here. And in this case you will see that there is a synthesis of that methyl acetate based on this reactive extractive distillation. So, distillation as well as extraction will be happening along with that reaction. So, reaction, distillation and extraction, 3 units will be working at a time here in a single unit. So, in that case that operation, task and phenomena will be considered to design this process integration for that process intensification process. As per Sirota proposed a combination of tasks that lead to the well known intensified solution of a reactive distillation column for the production of methyl acetate here. And for the final set of process intensification solutions based on this process integration, Babi et al proposed a phenomena based approach where combinations of set of phenomena lead to a set of tasks whose combinations lead to a task of new or existing unit operations when it will be combined. And also they have suggested or illustrated their method to methyl acetate production that has been shown in the previous slides, and reported the same reactive distillation solution as well as the other feasible process intensification solution. So, to get the final set of process intensification solutions, you have to consider the process integration, and also phenomena based approach will be the better way to think about the combination of the process or integration of the process. Here some examples of process intensification are given for the unit operations scale, task scales and phenomena scale. Like here some process, some hybrid or intensified unit operation that is called integrated process. Some that opinions are given here based on this different process. Like if you are producing some ethyl acetate, in that case packed bed reactive distillation can be designed as a that integrated system for the analysis of homogeneous and heterogeneous catalysts and process operation conditions. In that case you can get the more process yield for the production of ethyl acetate. And also for the separation of acetone, butanol, ethanol, in that case PDMS or ceramic composite membrane can be considered as a process integration. In that case molecular transport during the power evaporation is actually being analyzed. For the wastewater treatment like bioreactor, and in that case tasks you have to consider for the process integration, and in that case kinetic study for the that effect of oxidation process to be considered. And also production of methyl acetate for the task or functional, in that case reactive and distillation both should be considered as a functional task, and in that case all reaction and process tasks to be integrated. Crystallization, in that case crystallization should be coupled with the ultrasound process, and in that case effect of that ferroacetamol and that it is paracetamol crystallization to be considered, and transesterification of DMC with ethanol also, it is one of the important process where microwave systems to be considered for the intensification. In that case phenomena based or molecular based tasks to be considered. In that case impact of enhancing the reaction mechanism based on the investigation of this that microwave concepts, and also that reaction mechanism will be considered based on that microwave heating. And the production of ethylene oxide also important application for the membrane based reactor development, and in that case analysis of novel reactor design should be that considered for its conceptual design. And also production of isopropyl acetate, in that case analysis of the reaction and separation in that particular reactor of flat frame flow reactor for that power evaporation of this production of isopropanol or isopropyl acetate. And also there are important that hybrid operation, it is called divided wall column. In that case dimethyl carbonate is being actually produced based on this divided wall column. In that case effect on separation for the dimethyl carbonate and methanol is analyzed for that process integration for the process intensification process. So these are the different that applications based on the hybrid or intensified unit operation, and what are the different design consideration that has been given here. So I think it will be better to know that for the sustainable design based on that different scales to consider those that operating variables, and also that that some parameters based on the tasks phenomena based tasks should be considered there. So there are some mixing characteristics, and it is that depending on the physical properties of the system, depending on the that geometry of the system, depending on the that other parameters like energy distribution, all those things to be considered there. So I would suggest to know about this more, just going by this further reading of these textbooks given here. So I think you understood some extent of this process intensification design based on these sustainable concepts of designing that process for this process intensification. So next lecture onward we will discuss something more about the that design techniques of this process intensification for the sustainable design. So thank you for this.